We selected automated, progressive slip forming and precision grinding because it has major advantages over precast alternatives. Better value as it's cheaper and faster to install, provides accurate variable super elevation as well as following horizontal and vertical curves. Fully automated and free of hazardous repeated mechanical lifting operations. Monolithic continuously reinforced construction resists likely long-term residual settlement and/or movement. Improved ride quality as no joints and will be delivered to greater tolerances than can be achieved using precast. Our approach is to slip form the busway, followed by an automated mechanized precision grinding operation. We will purchase bespoke precision slip form pavers to construct the guideway. Our guideway features a continuously reinforced concrete pavement constructed upon a cement-bound material subbase in line with design manual for roads and bridges and the BritPave Guided Busway Design Handbook. An independent slipform machine will feed concrete to the hopper of the principal precision slipform paver. This machine reduces the workload of the precision slipform paver, reduces stress and wear, improving efficiency and accuracy. The concrete wagons will side-feed the leading paver. These wagons will use the adjacent CBM as a haul route to discharge for track 1. Gully grates draining water from the recess will be set in advance of slip forming. The slip forming mould will travel over them. Localized reinforcement will control cracking around the grates. The reinforcement for the busway pavement will comprise a combination of prefabricated cages, mesh and loose bar. It will be assembled in place on site. Strict quality controls will ensure the reinforcement has the necessary cover and bar alignments. The reinforcement position will be checked using the 3D modeling system to ensure absolute alignment. The main guideway slipform paver will feature the latest technology to maximize the accuracy of the guideway profile, including live sonic analysis of the surface regularity of the concrete profile surface and gauge exiting the mold. If the system detects concrete out of tolerance, it will stop the machine and alert the operators. Automated, recorded and analyzed concrete consolidation via monitored vibrators, maximizing operator control of product conformity and certainty of compaction. The guideway gauge will be slip-formed within an absolute range of 2596 to 2584 mm. Subsequent grinding will adjust this to 2600 mm plus or minus 1 mm. The newly formed guideway profile will be immediately and progressively checked for tolerance conformity using 3D control instruments. Final gauge tolerance will be achieved by grinding the upstand faces of both slip-formed and shuttered guideway after 14 days using a purpose-built machine. A 3D model of the as-built slip-formed guideway will be generated. The ideal route to be taken by the grinding heads will be derived to maximize ride quality. The grinding machine and the grinding heads will be aligned to this model using 3D wireless control. 3 sets of grinding heads operating in echelon per upstand face will be used to sequentially remove up to 9 mm of concrete per upstand. A second set of grinding heads will align exactly using laser measurement controls from the ground upstand face provided by the first set of heads. Live readings will be displayed and recorded to validate the achievement of the required plus or minus 1 mm tolerance. The grinding head's alignment will automatically compensate for wear. Pavement surface texture will be achieved by shot blasting using the same technique adopted for Cambridge and Luton guided busways. This proven process provides adherence to the project surface texture specification depth of 0.4 mm. It will produce a consistent aesthetic surface finish. Dust is completely eradicated as both abrasive material and waste arisings are vacuum extracted and recirculated. The machine will be fitted with noise suppression panels, ensuring noise emissions are within acceptable limits. Track 2 will be constructed in a similar manner, save that the concrete mixer trucks will access the feed paver using the previously constructed adjacent Track 1. Our guideway comprises a monolithic reinforced slab featuring a drainage recess between the tracks. The recess will be planted with sedum. The surface will provide a maintenance-free green area between the running surfaces, which can also be considered a drainage pollution mitigation measure. Our design will provide a robust and maintenance-free busway with no transverse and longitudinal joints and a life expectancy of over 50 years.